everyone. Welcome to this Learn Live session. We are going to learn how to start the machine learning lifecycle with MLOps. I am Cassie Breviu, and I am a senior technical program manager on the Onyx Runtime team. My background actually is a full stack C# engineer, and then I started getting into AI, I don't know, probably 5 years ago now, and I really love it. And I am joined here by Korey.
Hi, Cassie. Hi, everyone. My name is Korey. I'm the cloud advocate based out in Stockholm, part of our Microsoft Reactor program. I'm a huge passion of bringing sort of the promise of machine learning into the real world. And that's really what we're going to talk about today, about bringing ML into production models. So I'm super excited to share this knowledge with everyone.
Absolutely. And please tell us where you're from. I am joining you from Minnesota, actually, and I see someone is here from Ecuador. So that's awesome. This is truly a global event, and it's really cool to see where everybody's joining from.
But this is a learn live session. It's not a learn alone or learn by yourself. As Cassie had mentioned, this is live. We're kind of doing this together. And not only are we doing it, Cassie and I, but we actually have two expert moderators watching your questions in the chat. We'll call them the Davids, so David Smith and Dave Glover. They will answer questions that you have of us in a presentation, and feel free to ask once you have the question. I know it's super annoying. I don't know about you, Cassie, but like when I watch a talk, I go, oh, I have this really great question. I'll wait until the speaker is done. And then I always forget those questions.
Don't wait.
Just launch the question, ask away. We'll get those answered.
Yes, don't be shy. Ask all the questions. MLOps is hard, and we're going to talk about a lot about that in this Learn module. So this is the short link to go to Learn module to kind of flag it for later, because this is an enhanced version of that. We have a lot of content for you. We have more than what's in the Learn module. I'm super excited, but maybe you don't know what a Learn module is. Korey, what is Learn?
So Microsoft Learn, I would like to say, is like the best shop in the world because it's always open and everything is free. What it's selling is knowledge on almost any sort of technology, not just Microsoft Azure, but I've gone there to learn a little bit more about Rust. I was a little bit rusty on my JavaScript skills, so I also checked out some JavaScript modules. But it's got everything from Azure, Python, JavaScript, C#, .NET, anything that you might be interested in learning. And obviously, we're talking today about this beautiful module, starting the machine learning lifecycle with MLOps.
Yeah, and I know I really wish I had a platform like Learn when I was learning, because I'm self-taught. And I think it's funny, like when I went to the bookstore to get a book, I literally bought a book called Programming because I was like, that is what I would like to learn. And now there's just so many amazing resources out there, and so many good free resources for you to get started. So definitely take advantage of them. And there's also some cloud skills challenges going on. If you don't know what that is, we'll talk about it later, but you can get free certifications and it's cool. So let's jump into what we're going to be learning today. So we are going to identify the different steps of the ML lifecycle. We're going to describe how to create and manage machine learning models with MLOps. And we are going to look at the processes on how to monitor these models and respond to incidents. So I'm going to jump right in. And we're going to start out with the challenges. So the thing is MLOps is a solution, right? And when we come up with solutions in tech, it's usually because we had some problems that need to be solved. And there's a lot of problems that arise when you're trying to figure out how to work machine learning into your existing process. And I went through this. So I'm going to tell a story back from like when I first started learning and I was teaching myself how to do machine learning. And I was in a C# shop, and I was the only one doing AI, and I had got a model to work and I was really excited. And then he's like, okay, we need to fit that into our DevOps process now. My technology lead did. And I'm like, I don't know how to do that. And this was before MLOps was really even coined. I don't think it was really a thing yet, because there are some fundamental differences, which we're going to talk about. So there is similarities, right? So the challenges within MLOps or with machine learning is you still have these cross-team alignments, but now you have these data scientists that you need to try to figure out how to work into the process. You need standard repeatable processes so you can recreate models and retrain models and be able to make those better. We're going to say retrain a lot. Then we have large amounts of resources, people and technical resources that need to come together. we need to be able to audit, and we need to be able to explain. So we need to make sure that our models are meeting the regulatory standards that they need to. And then machine learning can kind of be a black box. So having things like responsible AI and understanding, like the responsible AI toolkit, and understanding how your model is making decisions in order to make sure that you're making good, fair models. So let's go back to our slides. And so when I bring all those challenges together, the goal of MLOps is to make faster experimentation and develop models well, right? Make sure that we're having that flow and the communication happening. Faster deployment to production, faster fixes, that type of thing, and kind of that end-to-end process. So MLOps is about bringing all of those things together, solving that with these goals in mind. So let's talk a little bit about how we actually train a model and how this works.
That's a good question. Yeah. I really like what you talked about the challenges, Cassie, because this, I think, is kind of like the visual representation of what's going on, and even kind of towards your story. Because I think once you're starting out with machine learning, like machine learning ops kind of seems a bit foreign, right? Because if you look at it and you want to work on your local machine, you follow these necessary steps, right? You prepare your data, and that could be challenging, finding the right data, cleaning it. There's a lot of even learn modules based on those things. Then we sort of build and train that model. We see the results. We see how accurate the accuracy and other metrics that we might be optimizing for. We evaluate that. Maybe we do a little life cycle, continuing, preparing the data again, getting new data sets, training new models. But it's all kind of happen locally, like to your point, right? It's all happening on your machine. You're ready there, but now we want to actually use what we just did, and we like put it in a box, and we just throw it over the wall into production. And there's a lot of things that happen when you're not prepared with this. And this is what we're really talking about here with machine learning ops, is how to prepare and put some standards and practice in place to do this right. And you mentioned DevOps earlier, and I really like that, because I think, yeah, DevOps, most people understand, and it's kind of like the accepted standard of software releasing software. And it has, some similarities to MLOps. I mean, obviously the ops parts of the operations, but DevOps is focusing on different things. So first we talk about code reproducibility, right? So not getting away from the meme of, oh, it works on my machine, why doesn't it work on yours? Like, Cassie, have you ever had that experience before?
Yeah, and I think machine learning kind of went through everything that they went through, like in the beginning of development, where you'd have like one machine and it was like running the whole site and there was no process, or you're just like copying files over from to the server. Like there's all these things that are happening now. When data science started getting popular, the data scientists didn't necessarily know about DevOps or these processes that need to happen. And so they have just like the model running locally, and then there was no way to like retrain, which we're going to be saying that a lot, aren't we, Korey?
Oh, yeah. And so we'll also do code testing within DevOps, right? So we make sure before we actually deploy, we don't want to be, the next press release or a part of a Twitter thread on the biggest fails of the internet. So we test code, we make sure it's ready to go, and then we actually deploy the application. And it's really nice. I mean, if you're building features or versioning software, that's a big point of the whole process of deploying the application, getting to users, whether your product or service. But MLOps is a bit different. So instead of working just with code, we actually work with data. And we'll talk a little bit more about how data needs to be looked at, retrained, refocused in case of how we're actually managing that and different versions of that. We also talk about model validation within MLOps. So not only are we making sure that we are getting the accurate results or predictions that we want, but then monitoring those over time. Again, we'll talk a little bit more about that as well, how to monitor and set up processes for that. Then we do model deployment, right? The big showtime of it all. And I like to say that, models aren't, features. So we don't just say we lost the feature, we've done it, high five to everyone on the team. The model goes out and it's like a living creature. And guess what we need to do with living creatures or models that are out in the wild? We need to retrain them. And as Cassie had mentioned, we will be saying that word a lot. I would like to start a little game here. And if I say model retraining, you drink a little bit of water, because if there isn't something more important than model retraining, it's probably drinking more water.
That's right. We're stay hydrated during this game.
Yeah, Cassie, thank you for showing everyone how to drink water, the world how to drink water. This is very educational.
I can demo more than just code, okay?
Yeah.
Okay, so yes, model retraining is important. Have your water ready so you can stay hydrated. Oh, and one other thing I wanted to say about that slide too is you can see like a lot of DevOps and MLOps. Like they're ultimately, we're trying to ship a product. Like that's the end of the goal, the end goal of both. We're trying to, the difference is just like the way that we make the product. With models, we're using data to create functions. And with static code and DevOps, you're deploying applications, but ultimately you're usually deploying an endpoint at the end of your MLOps that's going to be consumed by an application. So I think thinking about it in a way where they're similar and they work together, but there's different processes and different assets that you need to have as part of your MLOps process.
I like that word process because any good process has good components, right? And I like this slide because it kind of shows you'll probably see some familiar faces of your DevOps process now. So data collection, like I'm sure you have some sort of database or where you're storing data, and it might not be particularly for machine learning, but again, since we're talking about machine learning ops, we'll apply that. You again also have some infrastructure, some tools and systems in place to support that, and a CI/CD integration for actually deploying and having continuous integration. So those are like the familiar things with DevOps that share some similarities with MLOps. But then we kind of talk to new kids on the block, right? The things that you might not actually already have in place, which is really important. So the continuous training, which we didn't use the buzzword model retraining here, but that's what we're talking about here is, again, why is that important? Well, how do we adapt to the world, the shifting world and the data sets? We'll go into way more detail on that later on. Then we have a prediction service, like how actually we're serving those predictions, the speed, the way we actually meet our users' requirements or our product requirements is super important. And then putting that all together is actually the monitoring part. How are we understanding the predictions? Are they drifting or kind of getting away from the standards that we are expecting? And then again, if they are doing that, we probably need to do some model retraining. But this is like like level one MLOps kind of model here. I want to kind of show everyone. So first is the stuff that was trained model, which I kind of explained earlier, right? This is probably something, if you even done any sort of machine learning work yourself as a hobby project or even as working as a company, you're probably familiar with this stuff. But then the next step is kind of packaging the model, making sure you get all the libraries you used, the data set you used, things like that, all into a nice package so that when you can validate the model, you'll be ready and you see that these are the results that you want, you can actually deploy that out into the world and get that actually working. And again, we can't really stress the importance now, but after this, you deploy the model, you're bringing and you're monitoring the actual predictions because now users are actually using that and you're receiving the model predictions. That might look good for some time. It might be working, but after some time, you might need to retrain the model because, again, if you're putting all the monitoring into place, the data changes, people change, behaviors change, and we need to know how the model has now adapted to those changes.
That's right. So this looks really simple and easy. Like, look at these pretty graphics.
It's as easy as this, Cassie. Please don't ruin my perfect vision of MLOps. Please don't do it to us.
No, and in reality, like, it's complicated and there's a lot going on. And I think this graph kind of shows that. So this, like, there's a lot happening here. Don't worry, I'll zoom in. There's also a short link at the bottom there for you to go directly to that because I know you probably can't read all of this tiny text. But in reality, there's a lot of moving pieces happening and a lot of people involved in this. And it's hard. And that's why companies kind of struggle with that once they decide they want to do data science. And they're like, how do I actually do this, right? Oops. Oh, I don't have Zoom it, so I can't zoom. But
an imaginary zoom.
Have, what's
Squint,
that?
Everyone. Get closer to your screen.
It's really hard. So anyways, you have your business goals, and you need to make sure you have the data that's going to come in. And you can't really make a model without data, right? And from there, like in this example, we're going to be looking at a sentiment analysis model. And so from there, you kind of go, okay, I have the data. I need to create a data pipeline, and I need to have experimentation happening. So that's when your data scientists start working on it. And you'll see these kind of little green marks, the different people that are involved, like your data scientists, data engineers, or your software engineers. all of those different roles that need to come together and the different parts of the MLOps process. And so from there, you need to create your build and training and release pipelines, all of that good stuff. And then you generally deploy to an endpoint, which is down here. And that goes to your business app. And your business app is going to be querying that data. And you'll notice that observability is here because, like we said, the process is not over there. We need to monitor and make sure that everything is working because we might need to retrain if things are not working correctly. So again, sorry I couldn't zoom on this, but there is a short link there for you to go check it out. And I think this is a really great graphic. So now let's take a look at how we actually train a model. Like, how do we actually do this? So we're going to look at how we fine tune a BERT model. So BERT is a large language model, and there's lots of different versions of it. So we're starting with this one that Microsoft put out, which is a distilled version. So it's a technique for making a model smaller. And we are going to be using different Hugging Face libraries. Hugging Face is a really great contributor within the machine learning open source world. So if you don't know what they are, check them out. So we're going to be using the Transformers API and the data sets. And so we're going to load this open emotions data set in order to train our sentiment analysis model. We're going to grab our auto tokenizer. And I remember once when I said tokenizer, someone was like, that can't be a real word.
And it sounds made up, Cassie, to be honest with you. If I wasn't knowing what it meant, I would be like, okay, I'm going to turn this off now. We're making up words.
Yeah, we love our jargon in tech. And so basically all tokenization is, in like a really basic way, is taking words and turning them into numbers so we can process them. And so that's like the most simplistic way I can think about saying it. But, we have the big words because it makes us sound smart, and then they give you more money, right? That's why data scientists like, yes. Okay. Get paid. No, I'm just kidding. Okay, so we get our tokenizer, we create our tokenizer function, and then we're tokenizing our data set in order to train. If we go down here, we can see that we are splitting out our data to test and train. You don't ever want to test your model with the same data that you trained with. We're taking a look at the size of that, and we can also take a look at the different features that we have and the number of roles, because you really want to make sure that you have a good understanding of your data. And then here we are importing PyTorch, and then we are going to get our model here. And then once we get our model, so we're downloading the pre-trained model that we're going to fine tune from the Hugging Face site. We're setting up a compute metric so we can understand the accuracy of our model. And then from here, we're taking all of those arguments that we put together. So we have our hyperparameters, we're creating a trainer, and then we're sending those in here with our model that we're going to fine tune with our data set, and then our compute metric for understanding how it's performing. Now, I know I'm going through this fast, but don't worry, this code will be made available after in our resources at the end. And then to train, you just call trainer.train. And I'm going to use my outline here. So I'm using VS Code, and this is Jupyter Notebooks in VS Code if you're not familiar with this tool. But I'm going to jump down to the evaluate because there's a lot of printing out happening when it trains. And I'm not going to train it live, otherwise we'd be sitting and watching it for a while before we saw anything of use come out. And then from there, we get our evaluation metrics. So we can see that we got to a 92% accuracy with 24 epochs. And that's it. So that is a very quick kind of introduction of how you could train your model. So let's go back to here.
That was very nice. Very nice demo. But maybe some people who are joining aren't data scientists, aren't developers, but they are the ones paying the bills, or the ones going to make the investment into ML. So we also want to make sure that we include those folks, right? That there is some business value here for doing MLOps. We can't really stress the importance enough that it is about collaborating amongst the data scientists or ML engineers or people who you think are specialized in the world of machine learning, and your existing IT, anyone that's already knowledgeable of your infrastructure, and app developers. Again, as Cassie had mentioned earlier, we're talking about putting models or productive models into applications real world. So it is that combination of how to make this lifecycle efficient, scalable, and also, again, delivering the results that you are probably interested in when you're working with ML. And the apps part is really where the investment needs to be done, and collaborating with the team to bring them together.
Right. So we want to bring all of these people together. to create good products, right? That's the end goal. And so now that we kind of understand what MLOps is, why it's important, the challenges, kind of the overall process, and we understand how to train a model, let's dive into some more details about how we manage, monitor, and retrain. So why would we want to monitor and retrain our models, right? Like Korey said, we shipped them out, they're done. You don't want to just forget about them, and you want to test them thoroughly. And I have a story on this one. I feel like I made all like the data science mistakes when I started out. So on this model that I had working on, this was my first production model that I made. And I was testing it locally, and I was getting 100% accuracy. And I was like, I'm amazing. My model is 100% accurate. Like, put it in production. So anyways, I get it off, and this is just locally, I'm testing it, and I put it in our test database, and I start testing it on real data, and it was performing terribly. And it was not, in fact, 100%. In fact, if you ever have a model that is 100%, you should be very skeptical, because there's different things that can happen when you're training. And one of those can be inadequate training data. So for like a computer vision model, you need to have different lighting and different things like that in order to make sure your model can understand your data in all types of settings. And then another one can be overfitting. So in my example, what I was doing is I didn't have enough data. So my model had understood my data really, really well that I had locally, but I didn't have enough. So it was overfitted to my data, which is why it was performing really well. So the other thing that might happen where you have a model that you trained and your data scientist said it's awesome, and then you put it in production, is there's differences in the data. Like, you might not have had a good training data set that's actually representative of what the production data is going to look like. And therefore, you're going to have problems. And you're going to need to figure out what those are and retrain. And then there's also just naturally like model drifts and data changing over time. Just like we evolve, data evolves, and our models need to evolve, right? And so like a really good example is thinking of the stock market or something like that, where it's not the same, it doesn't continue to be the same, and you need to continually update something like that to stay accurate. And so that's not just something that happens in the stock market. That can happen with all models. As your business changes, you need to be able to make sure that your data is representative and that you're accounting for those changes. So then once you think you need to recreate that model, so now you have something called model reproducibility. So again, I'll go back to my example of the model that the first model I was working on, and I was training it locally. And when you're training models, you a lot of times are changing hyperparameters and different types of maybe adding features in to try to get better result. Like, you're trying to see how you can improve the results for what you're trying to get. And what I was doing is I was running locally, and I was exporting, and I kept exporting to the same model name. So I was actually overwriting my model every time I trained it. Nice. And if I had one that was a worse training, I had to try to remember what I had changed to go back. And so, like I said, I feel like I made all those beginner mistakes. And the way to get around that is by monitoring your assets in a way. So model registry would be one of those. So with Azure ML, there's a way where you can submit training jobs to the cloud, and then it has that there. But however you want to do that, maybe it's just creating version files locally every time you put it out. There's lots of ways to do that, but you want to be able to version your models. You want to be able to understand what the parameters and things were used to create that model. So now you have the code that's creating your model, and that is changing based on, your different fine tuning and the different things that you're doing. You need to be able to manage that along and understand which one of the models was created with that code. And then also you have something new kind of data set management. So you need to understand what data was used to create that model. So if my data has changed and I have a model that's out there that's performing okay, but I want to retrain, I need to know what has changed in my data, what features are coming out, what do I need to add, where is my data drift? So you need to understand where those data sets are. And then you need to be able to have this all in a shared environment so that any data scientist can walk in and understand where things left off, what model was what, and what they used to train that model, and then how to evolve it and retrain it in the way that it needs to be. And so we'll talk about tooling a little bit later on how to do this. But these are hard things to do. And it's important when you start putting models in production and doing custom training and things like that to be able to have these pieces put together and put together well.
I was very worried that you were going to not say model retraining at the end of that slide, even though it was on the slide. The people are dehydrated at home.
Thirsty, they need right? I mean, you guys may drink water without us giving you permission, just so you know, but
Yeah. Cassie, as you drink your water, and as everyone has collectively drinking the water, I'm going to talk about model deployment, because I think that's what probably most people rush to. Like, to your point, Cassie, right? You get your 100% accurate model and you're like, I'm the king, queen, ruler of ML world. Like, I've solved it. I don't know what these people are thinking, or it's actually a difficult thing. Like, it's just so easy. So you go there, and maybe one of the issues you might run into, especially when you're new to this process, is, okay, infrastructure, I'm ready. I've picked all these new tools that you don't know anything about, and I'm ready to deploy my model. And that's where a lot of times things go wrong. So really, again, as we have already talked about, looping in and using existing tools and looping in your infrastructure or development team to understand how you actually get your model into production, and using tools that they're familiar with, and not just something that you've pulled off the shelf as like a data science lover and you thought was cool, is probably another good way to avoid any issues. But there are some considerations when you're talking about deployment. And the first one is, like, again, to my point, how to add this to your existing CI/CD. We're not really advocating here to just go out and add new things that you already have in place that, again, you have the knowledge as an organization and expertise in. But then also you might be having different hardware needs that you might not already have in place. So depending on the type of model that you have, you might need to train using a GPU. So like if you're doing some computer vision, which is GPU intensive type work, or maybe you're just doing like some text classification or sentiment analysis, where a CPU would just be enough. Also the size of the model, Cassie had already mentioned around how we can kind of tokenize things and kind of make things more efficient. But that was when we talk about really about production as well. It's super important to talking about the number of requests you might get from users and customers. How can they sort of be comfortable how quickly you're responding with your predictions? I mean, to the stock market point, like nobody wants to sit around and wait for your predictions of the stock market. That's would be horrible. So again, making sure that what type of actual solution that you're putting in place will also be around considering the deployment type that you have. And lastly, and of course, most importantly, model retraining and data drift. But those are really considerations. Can we like optimize some of these things? Can we make it more efficient, Cassie? Please let the people know.
Absolutely. So I want to talk more about like the size and the speed of models and how we can kind of optimize those in ways to both save us money, because when our models train faster and inference faster, that's, time is money, right? So we want to do that. But also we might have different considerations, as you mentioned, around the different hardware needed to inference those models. And so I'm going to talk about some tooling that we can use and kind of show you how we're going to be able to take our sentiment analysis model and make it smaller so it can actually run in the browser on the client, which is pretty cool. So the first thing that we're going to talk about is ONNX. So ONNX is an open format built to represent your machine learning model. So you would train your model in whatever format that you need, or whatever training framework that you're using, whether like PyTorch or TensorFlow. And then from there, you export that to an ONNX format. And then once you have it in an ONNX format, you can use ONNX Runtime, and ONNX Runtime is going to have these different tools that we need to speed up our inferencing. It also allows us to inference in multiple languages, which is one thing that I ran into being in a C# shop and wanting to inference in C#, even though I was training in Python. ONNX Runtime also allows you to do that. So you can inference in JavaScript, Java, C#, C++. I'm probably missing some. But so when it comes to actually deploying your model, there's all these kind of different things that you need to think about, like you were mentioning. So what deployment target? So there's different execution providers that you can use in order to optimize that, like CUDA's example for NVIDIA. And ONNX Runtime supports a lot of different ones. So this is kind of, if you think about it conceptually, you train your model, you convert it to an ONNX format. Then once you have that, you use ONNX Runtime, and it makes it quite easy then to deploy to the different targets that you need. So now we're going to look at taking our model and seeing how we can make it smaller with something called quantization. And then we're going to actually deploy that and see how we can inference.
Another great word from Cassie. Tokenization, quantization. It's really happening here.
I have all the words, all the data science words. All right. So now if we go back to where we left off in our code here, ONNX is built right into the Hugging Face Transformers library. And if I scroll down here, you can see that I'm kind of setting up some different configuration, creating a pipeline, and then I am going to just export. So this is built right in. I'm going to send in my model, my tokenizer, my config, and then the path that I want it to export. So I've actually already exported this over here. So I have my fine-tuned model now for sentiment analysis exported. But the next thing I want to do now is make it smaller so I can inference in the browser with JavaScript. So I am going to use the Onyx Runtime quantization tools. And although it sounds like really hard and scary, this is like I'm doing it in this like one line of code because they did all the hard work for you. So you nice. Send in your model that you have. You send in the path for the out models, the model that you want to save it to. And then you tell it what quantization you want. And we're doing int 8. Now, at a very, very basic level, again, it's much more complicated than this, but just think of it as like making the numbers smaller so the model is smaller. That's the way that I like to explain it again in a way that sounds less scary than quantization. And then from there, we can export it. So now that we have this model exported and we were able to make it smaller, one of the things that can happen when you quantize a model is you can lose some accuracy. And so not all quantization tools are similar. So we're going to now take a look at how much accuracy we lost by reducing the size of our model so that we could put it into the browser. So here I'm just using Onyx Runtime. I'm creating an inference session and I'm creating one for my existing model and one for my int 8 quantized model. And then from there, I'm creating my input feed. And then from there, I am going to just call session.run and run both of these things. Now, I'm not actually running this because it takes time. But again, you can go and play around with this notebook after. And then from there, I'm going to get the predictions. I'm going to get the, and then I'm going to compute the accuracy. So with the first one here, you can see I was able, the original 92%, like we saw in the training. With the second one, I'm actually still at an 85% accuracy, which is pretty amazing. And for this particular model, it actually works still amazing at that. That's something, again, you just need to decide for your different scenarios. And sometimes you might have a model that you want to deploy multiple places. Like maybe you want to be able to inference locally and in the cloud. And so you might have different versions at quantized different levels and kind of make those decisions logically. So now that we have the model, we can see all that over here. I'm going to jump in and I'm going to go quickly into the JavaScript code. I'm not going to go into all of like the pre-processing and stuff here. There is a video on the Onyx Runtime YouTube channel where I do go into it in detail if you want to understand more. But so here I'm grabbing my tokenizer and then I'm importing the Onyx Runtime web library, which is going to allow me to inference in JavaScript. From there, I am setting up my options here. So you can choose which execution provider you want. You can use WASM or you can use WebGL, depending on what you're looking for and your model. And then the graph optimization level, I'm going to set to all. And then here you can see I'm loading the model and I'm creating my inference session. And then I'm going to jump into this function here and just show you quickly what happens. They create the output here. I'm sorry, the model input, which is our data that we're going to be passing in, the text that we're going to get the sentiment result for. We're calling s.run. We're sending in our input, and then we're getting that output, and then we're mapping it to an emoji, and we're getting our results. So what do you think? Should we run this and take a look?
Let's do it. It would only be right after you showed the code. We have to see it working.
Have to see it working, right? See that you can actually inference a model in JavaScript.
Fingers crossed. I didn't curse you here with the curse of the demo, but we'll see.
I think when I blue screened right before we started, so I think that curse has been passed, and now I love it, right? Okay, so now let's take a look. Like, hey, Ignite, this is awesome. You can see that as I type, we're able to get this result right here in the browser. And another cool thing, because we are inferencing in the browser locally, I can actually stop this and go back to my model. It still works because all the inferencing, everything is happening locally in my browser. So we are able to do that because we're able to reduce the size while maintaining the accuracy. And then when you're deploying, right, you can think of all the cool things that you could do with this now. All right. So let's go back to our presentation and talk about monitoring, right? We've talked about deployment, we've talked about training, and next comes monitoring.
It is the next step. It's the necessary step, I think. I mean, it's great, the demos. But then once we get it out, it's not just us, showing the world our product, but actual people using our, in-browser inference engine. Like, how do we know it's working? How do we know it's continuing working well? Like, I mean, monitoring for software, generally, we have all the performance monitoring metrics out there that we can reach out to. But with monitoring a model, it's different. We have different metrics, different things we're looking at as far as how the predictions are working. But, what are we monitoring for? Like, how do we reach out to that is kind of the next step. And there's two ways to monitoring models, I think. And one is an automatic and one is manual. And I think, if we talk about like the tech side of everyone, or we want everything to be automatic, because that's like, again, what we're used to as far as monitoring. And that is kind of monitoring around triggering alerts around performance. So if we notice accuracy levels are hitting a certain threshold, then we can trigger alerts to the team in regards to who and how to fix those things. Maybe we need to model retrain. I don't know, Cassie, maybe. But then there's actually a manual spot check as well, which could be actually needed for certain types of models. And this is using someone, maybe a data scientist, to go in and look at the actual results, maybe graph out the predictions over time. Again, it may seem more intensive if we come from just the DevOps world, but it's necessary, again, if we were talking about ML production models that are scaling and making predictions that could affect our business or our product or service. So it's important, and a combination of both is actually probably the healthiest mix.
Absolutely. Like, you want to do your manual checking, kind of like we talked about when you put things out in production, and make sure they're coming back the way you think. And automatic monitoring, I think there's like different ways to do that. Like, maybe you set static code thresholds, maybe it's unit tests. There's also different telemetry if you're using Azure services that have different ways to look at throughput, latency, number of calls, all these different things. And you can set alerts and dashboards, which we'll take a little bit of a look at how that works later. But yeah, you want to use definitely a combination of these things to make sure that it's performing well. Now, when something isn't performing, and if you didn't catch anything in your own monitoring, you might get an incident response, right? So you're going to get a ticket to your help desk. And so I think most companies, depending on your size, you have a help desk, you have like that level 1 person that your employees will call when they have an issue with an application. And these are like your operations people, your help desk people. And they're going to try to, triage that issue and figure it out. And I think in this particular scenario, this actually isn't that different from traditional development. Like, in a traditional application, you'd still have that first response person that's going to try to figure out what's happening and figure out if there's an actual issue to be reported. And if there is, then it goes to the level 2. And now, again, if you're a smaller company, you might go straight to the development team. In a larger company, you're probably going to have different levels of escalation. So in step 2, you would have a data scientist that probably wasn't the one that created the model, but knows how to debug them, understands what's happening, and can try to recreate the issue and figure out what needs to happen. If they're not able to resolve it, then it goes to the development team, and the development team would then go back and hopefully have all of the model registry, the data set that was used, all of that information that we talked about as resources, so that they have a starting point to understand what was used to create the model. And then from there, figure out what they need to do to retrain it in order to resolve the issue. So it's important to have a process in place in order to make sure that you can respond to these and respond to them quickly and understand what needs to happen.
And what might need to happen is, and I wish and I hope to promise that this might be the last time I say it, but what might need to happen is model retraining. And this is the model retraining slide that you've all been waiting for. I really like this slide, to be honest, because it does show you, and if you look at the graphs here, the differences of model accuracy and how it could decay over time. So on the left-hand side, we don't have a model that's been retrained. We treat it like every other feature that we have in our software or app. We'll release it, the users use it, and it's just stagnant maybe, or maybe we'll update it. But yeah, it's out there. The model's out there. We don't need to watch. It's okay. It's going well. No one's reported anything. But if we do regularly updated models, we can actually see that accuracy might even improve over time, because maybe we need to choose a different data set to the point, like, right, the world is full of data, but the world changes. If you look at the recent pandemic, like, customer behavior has completely changed across almost all industries. So if you're using older data set, Maybe you pull from pandemic data set now, post-pandemic data set. Like these things change, right? So you need to also version and manage that data and train your model on those things. You might also want to choose more complex models later on that may have better predictions. But you're not going to ever know these things. You're not putting the monitoring in place. You're not putting the incident responses in place and setting those notifications so that you can actually iterate and invoke new iterations of your actual process. And I know that might sound scary for someone that comes from like the world, just from the world of software. Like, do you just take your model away from production and then do some training with the data scientists and put it back out? Cassie, is that what you do?
No, absolutely not. Just like you can monitor or, use load balancers to move traffic around when you do deployments and things like that. The way that it's kind of done within prediction service for machine learning, or the way that I like to think about it and the way that Microsoft thinks about it, is to have two different deployments of the model. So you have your existing model and all the traffic is going to that right now, right? And you do a new deployment, and then you start diverting traffic to that. And this is where you'd start doing those manual checks to see, did my new model actually resolve the issue in production, make sure the consistency that existed before. Maybe you have different unit tests that ping the service, like all the different ways that you make sure that things are working correctly. But you want to do that on your production, on your new service, and start to change over the traffic to the new endpoint and see how that's performing. So this is kind of, I would say, like the safest way to do that.
Very smooth. Very smooth.
Yeah. And of course, now we have a demo to show you a little bit.
One more demo.
Because who doesn't love more demos, right? I do. Okay. So here is Azure Machine Learning. And in the studio, there's a lot of different, so you can do the full MLOps process within Azure Machine Learning. As you can see here, I'm in the endpoints feature, which actually has a blue-green deployment feature. And you can name these whatever you want. But you can see here I have 90% going to my default and 10% going to my green. Now, let's say I'm thinking, okay, this is going well, and I want to start moving more traffic. It's literally as easy as starting to move the dial and then hitting update, and then updating that. Sorry, I didn't update, I hit cancel. But nonetheless, you'd hit update and your traffic would start going over there. You could keep doing those tests and make sure everything was good. Eventually, you'd move everything over to the new endpoint. Now, another thing that we have in here is monitoring. And so since this is a test endpoint, I don't actually have any data in here. So I'm going to jump over to the documentation, and I'm going to show you a little bit about what's in the monitoring part of this service to kind of help you understand, how we think about it here and how it would work if you were using Azure ML, although there's definitely other things out there. So if I scroll down, you can see, like, we talked a little bit about like latency and those different things. This is optimized to look at those data points. And then we also have different things like our deployments. We have CPU and GPU utilization. So you want to make sure you're getting the maximum use out of that in order to speed up your inference and make sure that you're using those resources that you're paying for. And then you can even create dashboards and alerts, right? So we talked about manual versus automatic alerts. And if you take a look here, you can see that you can create different roles. And this might look familiar if you've used other Azure services, that you can go in here and you can set different alerts based on different thresholds that are important to you, and dashboards and all that stuff. So this is like very common within different Azure services that have hosting. But these ones are specific for machine learning and set up for our endpoints in Azure ML. So I think that's really super cool. It makes it really easy to do.
Very easy.
All right.
I mean, we did this on purpose to show you what hopefully is what looks like the easiest part of it all. Because, I mean, I think we all can take a collective breath in and breathe out. Because if this is all new to you, there's probably a lot of information, right? We showed you diagrams, some simple diagrams, some complex diagrams, some code, some dashboards, monitoring, all of these things we kind of threw at you. But if we reflect on some of the key or core concepts that we're talking about, one is to keep people in the loop. So keeping the right people in the loop. So again, collaborating with your data science team, your app developers, infrastructure, much like you might do already in your DevOps practice, but expanding that over into your ML practice is really what the essential thing is there. So you can put it in these right processes and investments into the right place. we also say like keep the first model simple and then like get the infrastructure right. So you don't have to like deploy this large language model or extreme computer vision model X just to really impress everyone. But like keep it simple, maybe something simple classification, or even kind of targeting a certain customer segment or a feature set or something like that, where you can actually just make sure you get all the processes like the notifications, the model retraining, anyone, all these things in place. And then lastly, stay calm. Like we shared all our kind of horror stories of our beginnings, how we thought we were amazing at ML, and then it didn't actually become true. Like most of this stuff is still very new concepts. There's new tools coming out, new processes that people are putting in place. So really invest the time into looking at those things. You keep calm, ML on, like we say. This whole presentation is not to scare you from doing MLOps, but to show you the processes so that you can get the benefits that you actually deserve as far as putting ML production models into place.
And help you get started, right? So that's like kind of the hardest part in a lot of this is how do I get started and start doing this? And I'm sure there's people on here that are just starting out with custom models and trying to figure it out. And there's also people that are probably further along in their process, and maybe they're having pain points and they're trying to figure out, how do I do this? Because there's so many different things that models need, as you looked at one of the considerations, right? So there's different things that you would need for each individual model, and those kind of can be customized to your different solutions. So think about what you need. The other thing to think about too is, do I need to build a model, like the buy versus build? Like we're talking about when you have to build something custom for your business and that you need to build one out of the box. But there's all kinds of services out there now, like the Azure Cognitive Services and all kinds of like no code ways and low code ways and APIs that you can just integrate in that solve a lot of the common problems. So that's the other thing is you usually have a combination of these things at a company where you have your custom models that you needed to build because they were specific to your business and your needs. And then you might have some pre-built services as well. Or maybe you're like we did, we grabbed an open source model and fine-tuned it for our scenario. So thinking about all of these pieces and how it all comes together and how it fits into your business and which pieces work for you, right? And so another thing that kind of, when it feels a bit overwhelming with development is tooling. Tooling is here that makes us feel better, right? At least it makes me feel better knowing that there are solutions out there that are going to make my life easier and they're going to help me be able to put my model into production and hopefully get the results that I'm looking for. And so I wanted to call some of these different tools out and talk about them just a little bit, very high level, just so people kind of are aware. Because you see the pretty diagrams, you see how everything comes together, but then what's the next step? How do we get our hands dirty? And so in this one, you can see, so data versioning, there's something called like FS as an open source data pipelines style product. Check it out. You might be using Git, Azure ML. Again, it has features for the full process, which I mentioned when I was showing you the endpoints. Maybe you're just using blob storage as versioning. You're exporting to an Excel and file and your model is in there. And you know what I mean? Depending on where you're at. And then MLflow is another open source product that covers the full process of MLOps. And MLflow you can actually use with Azure ML as well. So there's definitely different ways to use these, ways to use them together and get, configure it for what you need. Model versioning, maybe you're using GitHub. Again, we have a model repository in Azure ML where you can version different pieces there. Maybe you're just using blob storage, which is perfectly fine. That's where I started with my model versioning. And then also MLflow, like I mentioned. For CI/CD, I think most of us are familiar with these because you probably already use them in your DevOps process, right? You can use GitHub Actions, you can use DevOps, Azure DevOps, AML has it built in, or Azure ML. And then Jenkins is another popular one. And then MLflow also has things built in. And then the optimization and hardware. So we talked a little bit about that when I talked about Onyx Runtime. That's a tool that we can use to speed up training and inference and also make it easy to deploy to different types of hardware. There's another library called DeepSpeed to increase your training speed as well. And you can use those together, DeepSpeed and Onyx Runtime. And there's also something called Optimum, which recently came out from Hugging Face, which is another open source library that allows you to do different optimizations to your model. Onyx Runtime is actually built right into Optimum, as well as other optimization features.
I think the optimization group wins the award for the best naming, if I have to say so.
It's a pretty good name, right? We did
pretty good names all around, I think. Onyx, DeepSpeed, Optimum. These are all characters of my favorite show that never existed.
I believe if I remember it, we did this Twitter space. If you want to go check it out, where we talked with Hugging Face about creating Optimum. And I believe it was actually like a reference to Transformers. I don't remember the full story, but it's actually a really interesting story about how they came up with the name Optimum. And yeah, it is just a cool name, right?
Yeah, definitely.
And then lastly, model monitoring. So we talked a little about, automatic versus manual. Maybe you have serverless tests that hit your endpoint every once in a while and check with make sure things are working the right way. You have different monitoring set up in your app service or on your endpoint in Azure ML. You might have things built into the application. So like different thresholds and things that you want to be alerted on. Maybe when the confidence score comes lower than, whatever you decide, it sends out a notification. For example, if we're running our model in the browser, like we did in this demo, we'd probably want to have our monitoring happening within our application because we're not running it on a server on a cloud somewhere. We are actually running it in the browser locally. So we'd need to have some sort of monitoring built in. And then again, I mentioned, Azure ML and MLflow, they all have these tools. So when you start kind of thinking of this full process and you start thinking about what are these tools that I can use, where are you at in your process? How do I work these in? Here's kind of a starting point to go check out some different things and how they might work for you.
Cool. And having things work for you is really the important part. I don't know who taught me, maybe it was a movie or something, but someone told me, sales, it's a results business. And I think ML is also a results business because we showed you all these tools, we showed you the processes, how you have to bring people together, and you should be targeting some sort of outcome. But the only way you can actually get these like real results, real outcome, scalable solutions, the promise of ML, the predictions that we can actually receive is by putting these new processes in place. Like, you can kind of get away with some certain things. Maybe you can kind of get away with Cassie's 100% accuracy model for so long until like the users start using it. You actually maybe increase your user base into a different segment that you didn't expect. And then things start to fall apart. And that's where I think MLOps is the best at. Well, it's like really getting in a place where things don't need to fall apart. And even if they do, like I said, we were talking about the monitoring, the model retraining last time. All these things is really to help and reach your outcomes that you might be interested in when you even start to even like baseline plan for your ML or AI projects, right? So this is how you can kind of put those structures in place. Like we said, keeping it simple first, so that as you expand or grow, the rest of the business, whether the KPIs or metrics that they have tied to your ML project, they actually reach those things and they don't have to like die in proof of concept land or die in, that we tried ML, it didn't really work for whatever reason X. Like this is the kind of the promised land of putting those things, the steps in place and actually reaching those goals. So I think hopefully we didn't scare you or anything like that. We educated you on these things so that, again, you can really start building ML production models and reaching those goals and targets that you want, those results that you need.
Absolutely. And I always think, when I think about MLOps, I think about like data science is growing up. Like, it's growing up and it's having good practices.
The baby, the kid in the kid, get away from the child's table. MLOps. That's what we should have been
grow up. Okay, so we talked a lot about a lot of things. Let's now have a pop quiz. Let's see how much we can get through here. Okay, so first question. Oh, and there's a poll here that will be posted in the chat so you can answer the questions. What is
I'm ready
a
for
benefit?
This.
What's
I've been listening.
Okay, you ready?
Yes.
Good. Okay, what is a benefit of the machine learning pipeline?
So I'll start at the top because that makes sense. Machine learning pipelines create dependent workflow processes. Ensure each stage of a workflow is tested and completed. So I think we did talk about that. We talked about pipelines. I saw that diagram that you showed that had pipelines in it, workflows we were testing about. So that seems right. The top one, first one, right?
It's not that one. I mean, it sounds cool, but it's not quite it.
Okay. So this next one, B, machine learning pipelines serve as an audit trail for models history. You told that great story how you were erasing all your models and model versioning. And Korey, I think I did mention something about automatically triggering workflows. Is this it?
It's still not it.
Okay. So C, as it always should be, right? Machine learning pipelines require data scientists. We definitely talked about requiring data scientists to begin their work, to make changes, which improves their accuracy. Yeah, we always want to improve accuracy there. So that surely is it.
But still no. The answer is D. So having independent steps saved to a pipeline that allows multiple data scientists to work on the same pipeline concurrently. And this was confusing with me. When I first started too, like I feel like other people that are coming into the machine learning space, you hear pipeline and you think like DevOps pipeline. Yeah. But in machine learning, it's different. It's the steps that you are doing in order to create your model. So think of it more as like the way that I finally made sense to me is when I was thinking about like you have an executable program and you have each function that you're calling, like a pipeline, a data pipeline, or your pipeline to create your model is like multiple steps put together to create a model. So that's like your machine learning pipeline, and it makes them really repeatable, and it's important. Okay, you ready for the next question?
I am ready. I'm almost ready for even like the right answer. Just like, give it to me.
What is the recommended approach for monitoring machine learning models? We talked a lot about this.
We talked a lot about it. I mean, A is talking about thresholds again, alerts. B, we're talking about manual spot checks, which I do remember I said that. Some manual spot checks. And D is talking about CI/CD, which also something I mentioned. So it's a really tough one here. I
know, and it's like, it's not just one though, right? Maybe this one, the A is talking just about automatic and B is talking just about manual. And I think we want both, right? We want a combination of automatic, and manual spot checks. Okay, we want to have both of those within our process. Okay, what is a model registry?
So
I desperately needed.
Yeah, since I'm 2 for 2 getting this wrong, I'm going to go ahead and guess here. I'm going to say A, a central place to save every version of every model. You're
correct. And this one, I mean, I told the whole story about overwriting my model and how bad I needed a model registry. So I hope people remembered that. And now when they have it, they can think about how nice it is that they're not overwriting it. So yes, we want to be able to have a version of every model that we create. Okay, in summary, let's see here. And also, if we have time to answer any questions live, feel free to start entering or adding those now. I'm not sure if we'll have time.
Yeah, we don't have time actually. It's running out.
You don't think we will? Okay.
No.
All right. So just to go over what we did is we talked about the full ML life cycle. We talked about how to create machine learning models. We fine-tuned a BERT model from Hugging Face and then deployed that to the browser. We also talked about the importance of monitoring and retraining. I had to get one more in there.
Hey, one more time.
And responding to incidents to make sure that we are making our models continue to perform well.
So this doesn't have to end your journey as learning more about MLOps. We have this link here as a PDF, some white papers, more information around that. We also have some additional resources that Cassie had mentioned around the actual demo. So if you like want to get actually your hands on those things, make sure to save those links or scan the QR code.
Yes, absolutely. Maybe take a screenshot of this or pull your phone out or something so that you can go check out these resources and continue it. This is definitely, these sessions are meant to be your starting point. You can rewatch this session. So if you want to come back and kind of go through the whole process with us again. Yeah, stay hydrated. Maybe you just need to remember to drink water. So you just rewatch this session to make sure you hit those water goals.
Yes.
all of those things. But really, this is meant to help get you started because sometimes that is really the hardest part. So again, here is a link to that Learn module if you want to go back and check that out. And also, you've probably heard about the Cloud Skills Challenge, and we've talked a lot about Microsoft Learn. You can get free certifications. This is so cool as part of Microsoft Ignite. And so go check that out. It's at aka.ms/learnlive. And you can go there, check out the different ones that are there, sign up, complete one of the Cloud Skills Challenge. You'll get the free exam at the end. And we are so glad that you hung out with us today, and I hope you learned a lot.
I hope you did. Bye, everyone. Enjoy Ignite.